Good day, and welcome to our webcast. IoT-based integration supports predictive maintenance and production scheduling. Brought to you by CFE Media and Technology and sponsored by Aviva and GE Digital. We're joined today by Mohammed Abu Ali, CEO and Managing Partner, IoTco, and Edsel Lapira, CEO and President, Predictronics Corporation. I'm Kevin Parker, an editor with CFE Media. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on the completion of this program will be reported to RECEP at recep.net. In this webcast, two highly qualified speakers will discuss the use of predictive maintenance functionality working in tandem with production scheduling to optimize manufacturing operations. Besides presenting a general overview of the recommended framework, today's speakers will focus on use cases that demonstrate return on investment. They'll also look at some challenges frequently encountered in these type projects. Finally, they'll review options for integration of the industrial Internet of Things with maintenance, production, and other type operational and enterprise systems. As project participants, the speakers will share some of their recommended best practices. A systematic approach to improved operations supports engineering managers in their efforts to think big, start small, and win ROI. You see before you the learning objectives for today's session. This event is a live educational webcast presented on March 24th, 2022. The educational category is Technical, Health, and Safety. Here are some tips to help you get the most from today's webcast. If you experience issues with the slides or audio, refresh your browser or click the Refresh Media button under the presenter's picture. Control the volume of this webcast by adjusting the volume on your computer or on the webcast platform. For technical problems with audio or slides, click on the question mark at the top right corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. The Ask a Question box is also used to ask the speakers questions. The live Q&A session will begin after the presentations conclude. Today's webcast is being recorded. You will receive an email within a week with a link to the on-demand event. To take the Learning Unit exam, use the Learning Unit exam tab option at the top of the screen. The exam will open in a separate browser window. You can complete the exam after the webcast. However, the link will break when the webcast signs off. We'd now like to share with you two brief videos from today's webcast sponsors, Aviva and GE Digital.
Your data has power. It can improve asset reliability, product quality, and production performance to maximize your overall equipment effectiveness and optimize your value chain. But it can't do this alone. To realize its value, data must be made accessible and presented in context to bridge your organization's functional silos and ignite collaboration. Aviva connects your data to a digital thread, enabling access to AI-driven insights enriched with prescriptive guidance to mitigate risk, improve safety, and operate more reliably. With full visibility of actual production constraints and shifting demand, your connected workforce can respond to change quickly and optimize operational execution to reduce unscheduled downtime, improve productivity, and promote sustainable growth. Aviva, we help your data power new possibilities.
What the world needs now is people. People who see things just a little bit differently, who go out of their way to find a new perspective and a new way forward. Because seeing a smarter, healthier, cleaner world isn't something that's far in the future. It's something we're building now. GE, building a world that works.
Welcome back. I'd now like to introduce today's speakers. Dr. Edsel Lapira earned his doctorate in industrial engineering at the University of Cincinnati and served as the Associate Director of the Center for Intelligent Maintenance Systems, a world-renowned research center specializing in industrial predictive analytics. As Predictronics Chief Executive Officer, Dr. Lapira aims to deliver tools that provide fast, accurate insights, increase productivity, and reduce downtime. Dr. Mo Abu Ali is the CEO and managing partner at IoT-Co, the Internet of Things company. He is a strategic and transformative technology and business management leader with a 20-year record of achievement, driving and sustaining change in manufacturing. Dr. Abu Ali serves industrial and manufacturing clients in automotive, aerospace and defense, and others, providing digital transformation, industrial IoT, and predictive analytics technology and services, as well as running the IoT Academy for Industry 4.0 training. Mo has a doctorate degree in industrial engineering and has worked with companies that include IBM, Procter & Gamble, Omron, and Toyota. Mo, welcome to today's webcast, and please go ahead.
Thank you so much, Kevin. Good afternoon. I appreciate the opportunity to be part of this presentation webinar. Also appreciate being here with Dr. Lapira to give this joint presentation. So there's really 4 topics we want to discuss today. And I will set the stage on some terminology that many of you have been hearing about, including what is IoT, what is IIoT, what is the role of predictive analytics. Dr. Lapira will give us use cases, actually, on tying IoT and predictive analytics with enhancements in production scheduling, as well as enhancements in maintenance scheduling, which are 2 key pillars of running a smarter factory operation. And we'll give a conclusion and some guidelines on how you can quickly use AI and generate ROI for your business. So thanks for the opportunity to be here presenting on this important topic. So let's get started. Predictive analytics is one of the primary tools that utilizes artificial intelligence solutions and utilizes the bigger scope and landscape of the Internet of Things. So if we start at the top, IoT is an all-encompassing domain. It includes many types of industries and the connectivity of many things and devices around the world. And by harnessing the internet and utilizing the cloud and using connectivity and data capture, everything around you is connected, from airplanes you fly in the sky to your smart home that may be collecting data using intelligent thermostats and so on and so forth. But when it comes to the industrial space, which is the area we play, the industrial IoT is about supporting factory operations to produce better, to maximize uptime, and to maximize quality of the output. And therefore, the field of the Industry 4.0 was actually an initiative initially born out of Germany and Europe, and later on expanded around the world. In the United States, North America, for example, the National Association of Manufacturing, NAM, may refer to it as Manufacturing 4.0. It is about the convergence of information technology and operational technology. And if you look inside your factory today, or any factory, you have 4 layers on the left side. You have machines, you have data acquisition, you have manufacturing execution systems, MES, and you have your business system, your enterprise resource planning. And the unfortunate fact is, in many companies, those layers may be siloed, they may be fragmented, they may be missing, they may be outdated. And therefore, Industry 4.0 is all about the convergence of those 4 layers to help companies become more efficient. So at the bottom of the slide, you see some of the considerations when we're working on an analytics strategy towards Industry 4.0. And one of them is technology selection and the convergence of those layers together. Second is analytics, which we're going to talk about today in more detail. and how to become more predictive and even prescriptive, and providing better, more enhanced production and maintenance scheduling. And this all requires, number 3, connectivity. How do I capture real-time data, and how do I integrate data from the shop floor to the top floor of that pyramid, the automation pyramid that you see right there? And it all boils down to, what is the business case? One of the biggest challenge of implementing AI and predictive analytics, and to be honest, any IoT type of solution, is establishing a solid business case and delivering that business case in a short period of time. And therefore, I'd like to start setting the stage by talking about the business case. I mean, the vision here is using those tools to drive toward a more zero downtime, near zero defects mode of manufacturing. So in order to do so, we have to define realistic KPIs, realistic key performance indicators. And one of those key metrics used in manufacturing today is OEE, which is the overall equipment effectiveness of the plant. And some of the improvements you've seen here, based on these numbers, are actually manufacturing clients that have embraced Industry 4.0, embraced predictive analytics, and were able to make substantial improvements to their business. Clients are seeing improvements within a short period of time and achieving a very strong return on investment. But if we look specifically at predictive maintenance right there in the middle, because that is a key use case we're going to discuss today, predictive maintenance is there to support organizations to move away from a fail and fix preventative mode of doing maintenance to a more predictive and prescriptive mode of doing maintenance. And you can run predictive maintenance solutions as standalone solutions, or you can tie them with existing systems that you have in the plant. And 2 of those systems we're going to talk about today. One is production scheduling, and another one is your CMMS, or your maintenance system. And by tying them with production scheduling and maintenance systems, you're able to gain further improvements. You're able to optimize the use of spare parts. You're able to reduce spare part inventory in the factory. By being more predictive, you know which machine is going to fail and when it's going to fail before it fails, and this allows you to optimize spare parts, in addition to optimize scheduling of the machine, to optimize scheduling of labor to fix the machine, and so on and so forth. So some of the key metrics like mean time between failure, mean time to repair, which are important metrics for the maintenance organization, can truly be improved. We've seen clients eliminate overhead maintenance activities. They stopped firefighting and doing maintenance on weekends, Saturdays and Sundays, and having an optimized and predictive schedule to run maintenance when maintenance is available, Monday through Friday, for example. So we're going to focus heavily on predictive maintenance and how it can tie to enhance scheduling and enhance production planning in the factory. And my colleague will go deeper in this area, but I want to show the high-level view of predictive analytics and the idea of having a worry-free process, a worry-free scheduling process for production, and a worry-free maintenance process for the maintenance organization. And it's really all about 3 layers. The first layer is data and connectivity. We need to capture the right data from the right source, and it has to be done in an affordable and reliable and scalable way. Data can be coming from the machine controller. It can be coming from quality systems. It can be coming from your scheduling system, whether it's in the ERP or whether you're scheduling in your manufacturing execution system or your IoT platform. So we're going to talk about what data is required. We're going to talk about how the AI solution can be configured, and then how the data can be sent out to those third-party systems like scheduling and maintenance, so you can become more predictive. And there's really 3 key metrics that predictive maintenance would, empower the organization. One is health. Is my machine healthy? Is my process healthy to continue running with uninterrupted or unplanned downtime? Second is, what is a prediction of that remaining useful life? When is that machine going to fail or component going to fail before it fails? And what is that level of accuracy? because that is my lead time to allow me to be able to schedule maintenance and schedule production planning in a proper way. And last but not least, what's a diagnostic, right? Which part of the machine is going to fail and what is the root cause of the failure, so I can maybe order a spare part at the right time, or even make a decision to order a different spare part for the machine. So a lot going on here, but really the idea behind predictive analytics as kind of an enabler to Industry 4.0 is you need to capture the right data, you need to analyze the data in the right way using machine learning and advanced analytics, and then you need to have that user experience and that data sent to the solutions in order to schedule and plan in a predictive manner. And therefore, there is a process behind it, and we're going to be referring back to this process throughout the presentation. First of all, there is data collected, number one, depending on the type of use case, depending on the type of machine, the type of process. We refer to these as templates. Second is there are features, basically statistics, mathematics behind the scenes. Those features are indicative of what's happening in that process. So that raw data is basically transformed into features. Those features in number three are training an AI model or a machine learning model, which is a subset of AI, in order to build a fingerprint or a signature of the condition of my machine or component, and then allowing this to become repeatable and scalable, number four, as well as predictive, delivering the health and the predictions and the required diagnostics so that the production planning, scheduling, as well as maintenance scheduling are really transformed continuously as in number five, as well as deployed and scaled quickly within the operation. So hope this gave the team some understanding of the terminology as well as the idea behind what are we presenting today. And it's my pleasure to introduce Dr. Lapira to talk about the first use case actually of how to improve use predictive systems to improve production scheduling. So welcome, Edzo.
For this section, I'll be focusing on the educational aspect of what you will learn, including predictive maintenance and predictive scheduling, and how they can be combined to drive real value for your business. I'll also talk about the digital journey, what data may be needed, what software you may already have or may have to add, what infrastructure may have to be put in place. And towards the end of my section, I will provide a brief illustration on how the system would work and some summary points on how you may get started. So with predictive maintenance, you're looking at a more condition-based approach for performing maintenance. As an example, if you think about your car or vehicle that you drive every day, you may have to change oil every 3,000 miles or so, which is a more preventive maintenance or a time-based or a schedule-based approach. What we're working towards with predictive maintenance is finding early indications that the machine may have, some symptom that's starting to degrade, or early symptom of failure, and performing maintenance more based on the condition of the asset that includes related technologies such as condition monitoring, detecting fault at an early stage, fault diagnosis, and a prediction when it may fail. And that can be combined with scheduling, which I'll talk more about later. And if you make the right decision on when to perform maintenance, you can ultimately reduce downtime, increase productivity, and reduce the inventory for your operation. Now, this is an example of a predictive maintenance dashboard. This came from a previous deployment that we did for an automotive first-tier manufacturer on predictive health monitoring for industrial robots. Now, this is a dashboard that shows one of the robots that was initially healthy and starting to degrade over time, and eventually it developed a problem. And our prediction was saying towards the end of the screen there, it's saying that in the next month or so, it would need a more immediate action. And if you look at the bottom of the screen, it's also indicating that a particular part of a robot, in this case, joint or axis 5, was the main contributing component that was most severe. So this, again, is an example of a predictive maintenance solution dashboard. It consists of an assessment of the machine's health, a prediction of the future health condition, as well as an indication or where you should go and look to address this potential issue. So how can predictive maintenance be combined with other existing systems? First, let's review some terminologies and applications that are already being used by various factories and organizations. First up, we have ERP, or Enterprise Resource Planning. And this is more for managing operation resources that go into making a part. Meanwhile, MES, or Manufacturing Execution System, is more focused on facilitating and automating manufacturing operation processes. It can also be a repository of various operation information. So some of the data in MES would be the data inputs for doing predictive scheduling, because it contains information pertaining to the production jobs or orders that the machine has to accomplish. So it's very important to combine that data with health information generated by your predictive maintenance solution. Thus, integration would be a key enabler to go from predictive maintenance to predictive scheduling, which would ultimately drive better decision and higher value. So what could be achieved by combining predictive maintenance solution with an MES system? So there are various ways on how predictive maintenance capabilities can be enhanced by integrating with MES or third-party applications. And one of those is the production and maintenance integrated scheduling, which I'll talk more about later. In addition, MES solutions also provide a measure of overall equipment effectiveness, or OEE, for the machines that are being monitored. It would be interesting to correlate and have a unified dashboard to understand the OEE of the machine as well as the machine health. Another one is integration with maintenance management system, which Mo will talk more about later. For example, a machine is degrading and we're predicting an issue will get worse in the next month or so. Maybe we want to schedule a certain maintenance activity through a work order to dispatch a colleague from the maintenance department to go check it. So let's look at a potential framework for integrating a predictive maintenance solution in an MES application. So in this example, you can have any type of manufacturer. For the use case that I'll be describing later on, I'll be using a CNC machine as an example, but it can be any other type of asset or equipment. Now, for this machine, as an example, we will be using a CNC, and then with CNC machine, we usually look at different components, right? We usually look at spindle and the bolt screw. But for this application, we are going to use machine parameters as well as sensor data. We can observe the changes over time and develop a predictive understanding of the machine's health, and that information can be related to the machine and component health, as well as corresponding diagnosis of the potential issues, as well as a prediction of when that component may fail. And with that combined information from the MES, including production information, you can then use to have a more dynamic scheduler. So you can understand the upcoming production order, and you try to find the optimal time window when to perform maintenance, the risk that the machine may fail in the upcoming weeks, and also the potential orders that have already been lined up in that machine. So with predictive scheduling, what we're aiming for is to combine production information and maintenance information, as well as an estimate of the machine's health to find that optimal time when to perform maintenance. And if you look at what really drives better decision-making action, it's not only that there's a problem, but when you should also act. That's an important aspect why predictive scheduling is a value add to the existing predictive maintenance capability. Now, in order to achieve predictive scheduling, one would need the following components. You definitely need to have a predictive health monitoring system in place. One would also need the production schedule from the MES, as well as the maintenance information. So with those systems in place, you can achieve the benefits with better decision-making, such as increased productivity, better maintenance scheduling optimization, and a reduction of spare parts. Now, with those concepts in mind, this is an example of a screenshot of the combined health monitoring and predictive scheduling dashboard. It's showing the machine health that we had seen earlier from the existing predictive maintenance system. But if you look at the top of the screen, the top right, it's showing more clear, actionable information, such as when to order parts and how much time until repair should be ultimately performed. At the bottom of the screen, it's also showing the upcoming production orders and the risk associated with performing that order, given the machine may stop mid-order. Now, green means that there's no or very little risk. Yellow means more moderate risk. And as the machine degrades more, it will turn red. So this can give you a better actionable information whether you can meet the next production order or not, or if you should be performing maintenance in between that time period. So what value does predictive scheduling bring to the end user, and how could it help their job easier? So reviewing the existing products that are being combined in this topic, as well as other functionality and value, with MES, you're looking at the shop floor management and OE monitoring. And what that provides, of course, as a standalone application would be better visibility among many other benefits. For predictive health monitoring, you're looking at machine health, finding early symptoms that something is going wrong, as well as diagnosing those problems. Same in place, you can reduce unplanned downtime. But with the two combined together, you can still benefit from the existing functionality that both already have, but you can add the benefit from the integrated system, which includes optimal scheduling for doing maintenance, as well as unified dashboard that would allow one to correlate OEE and machine health together. Now, we spoke to some of our customers, and some of the improvements we've seen include a reduction in downtime, as well as an improvement in OEE. The values may vary depending on the type of industry, as well as other factors. Now, looking at a specific application for predictive maintenance, let's look at the CNC machine use case, which is a popular template for us. Now, there are usually a set of common critical components that we focus on. A popular one is spindle bearing. The focus for spindle would be the front and rear bearings, and we're looking at the data from add-on sensors such as vibration. Usually, we have an accelerometer placed on the spindle housing. But we also get data from the machine controller via various protocols, either using OPC UA, MT protocol, what have you. And the controller data would be more contextual, like the spindle rotation speed or RPM, the spindle load, as well as the program number. Those would be good contextual information pattern and understanding the health of the spindle bearings. In a similar manner, the other key component that I'll be focusing on today is the linear ball screw. And the common failure mode with the ball screw are usually a preload loss, lubrication issue, and other issues like wear in the ball nut and so on. With the ball screw, it's very challenging to install add-on sensors. Furthermore, based on our experience, the data from the controller is usually sufficient to build the health monitoring models for the ball screw. In this case, we actual load, position, speed, and the corresponding commanded values for those parameters. These signals, based on experience, have been insightful for building the predictive maintenance model in understanding the health of the linear axis or ball screw. So with those concepts in mind, we went ahead and demonstrated this integration through a project funded by MXD organization. They are focused on digital initiatives in manufacturing, and they are looking at technology to demonstrate it. And it's really a good collaboration. We had a university partner. We also have an MES software vendor as a partner. We, maintenance solution provider. And then finally, we have an aerospace manufacturer as the end user, which provided the factory data. Now, this collaboration was focused on developing the capability as well as demonstrating it in an actual factory setting and deploying the solution and then receiving feedback from the end user. In this case, the solution included both the unified dashboard as well as the dynamic scheduling, and it was applied to a CNC use case, around 4 units. And the impact is that it's able to affect how they schedule maintenance and ultimately it improved equipment availability for them. So there's definitely more that can be done, but it's a good first step in providing out the integrated solution. So diving a bit deeper, this is one of the tabs in the unified dashboard. It allows the end user to input some parameters for each component. These parameters are utilized to find the optimal time to do maintenance and order spare parts for these components. These parameters include spare parts inventory cost, the downtime cost per day, overall maintenance cost, shipping cost, and delivery lead time. Now, the following slides that I'll show you will illustrate a time lapse on the simulated data to demonstrate how the integrated maintenance and scheduling system works. So this is how the dashboard looks like in the early stages of the component's life when it's still healthy. If you notice top right portion, there's no prediction yet since there's no trend. There's nothing to base our prediction out of, and everything is still healthy. Now, once the system detects a trend as the machine is run further, then it makes a prediction. In this case, it's saying that there's a total of 63 days to perform maintenance and 51 days to order the replacement part. The difference of the two allows for the delivery and installation of the part, including the commissioning of the machine. Now, this is what the dashboard would look like if the machine is allowed to run further without any intervention or maintenance action. As you can see, you're at a high risk in completing any of these orders, and it's saying that maintenance needs to be performed immediately if the machine hasn't failed yet. So as a summary, here's the sample data list that we would need if we were to set up a predictive maintenance solution for CNC machines, and we're interested in spindle bearing and linear axis or ball screw related events. You would need a different set of data parameters should your priority be another asset or equipment. For spindle, the vibration signal is a major requirement. This can be measured with an accelerometer. Other signals we would need would be spindle load, spindle rotation speed, and the program ID for as contextual information. Meanwhile, for linear axis or ball screw, we would need controller data only, such as the actual axis position, speed, load, and the corresponding commanded values for those parameters. Meanwhile, for the predictive scheduling piece, we would need the following information. I've divided them into two categories. We have the dynamic data that would come from the MES application. This would include the production schedule, so the start and end timestamps or dates for those scheduled orders, operation number, purchase order number, and the data can be continuously retrieved via APIs, so the schedule can be updated regularly. Meanwhile, there are also some static information, and some of these can be retrieved from ERP. So we would need this information to calculate how long until parts come in when they're ordered and the associated costs. So with that, I'll pass it back to Mo for the rest of the presentation.
Edzo, thank you so much. I think it's an important use case of how predictive analytics can not just help maintenance, but also help the production scheduler ensure continued production in the plant. I do want to talk about a second use case, which is tying predictive solutions to your CMMS system. And CMMS stands for Computerized Maintenance Management System. So some examples of CMMS systems, and sometimes referred to as EAM, Engineering Asset Management Systems, include systems like SAP PM and IBM Maximo and many others. In many cases, the ERP system itself may have a maintenance function or a maintenance module. And in other cases, it could be a third-party maintenance tool, or it could be part of the MES system. So whatever CMMS you use, it is important to understand that you can run predictive maintenance solutions as a standalone solution. In this case, they'll be capturing data from the asset, such as the CNC machines that Edzo was showing, and the ball screw and the spindles. You can also capture add-on sensory data like vibration that Edzo showed. And obviously, by having this link here that you see from the asset to the predictive system, provides you a machine health dashboard and predictive insights into future failures. On the hindsight of that, it's natural to extend the models and to extend the integration and to have the ability to auto-generate work orders and requests for spare parts from the CMMS system. So rather than having a separate predictive solution, you can actually tie the output of that predictive solution and have a closed loop system that can auto-generate work orders that we would call a predictive work order. They may be flagged differently from the PM work orders and allow you to actually have a closed loop environment with your maintenance system. So that really further enhances and supports the maintenance organization. So they don't have to look at two different systems. The data can actually be immediately shown in your maintenance tool. This improves labor efficiency for the maintenance organization and also is able to tie in to maintenance scheduling and spare part management in an effective way. To show you a little bit of the detail, and it's a busy slide, I want to summarize it by saying there's usually two API interfaces between a predictive system and your maintenance software. And API stands for Application Programming Interface. So it's an interface, and there's different types of interfaces. There is a REST API. There is XML-based integrations. There is a JSON. There is MQTT, which was a previous webinar we did with CFE on how to leverage the broker messenger of MQTT. So these are all examples of interfaces. So whatever your interface is, you have to check with your maintenance software provider, and you have to see what interface they support. But the first API integrates the master data between the predictive software and the maintenance software. So there's a handshake to understand what are the machines, what's the asset hierarchy, and things of that sort. And then the second API is the one that actually takes that predictive health value and prediction and does the creation and auto generation of that work order request. Okay, so there is basically a master data handshaking API back and forth, and then the second API is the one that, based on rules and predicting when the machine is going to fail, would then auto generate the work order in your maintenance system. So I'm just simplifying what's on the slide here. And a quick example of a maintenance dashboard from a predictive system is shown here. And what you're seeing is the health value is rising, and there is a predicted failure that's going to happen on this machine in the short term. And therefore, a pop-up would enable the maintenance organization to also input additional comments if required. They will be able to save that comment, as well as request a work order to be automatically generated from your predictive tool to the maintenance software. Okay, and it's important to understand here some of the information that is coming back and forth from the API. So as I had mentioned, there is some master data that is coming back and forth, such as the asset description, location, and so on. And then there is information that your predictive software can send out. So for example, who is requesting the work order? So John Smith is logged in right now. He's the maintenance person, for example. And what type of request definition? And do you want to input comments? And then most importantly, the predictive system identifies that there is a specific failure, and it identifies a diagnostic, for example, joint 5, okay? And it can also identify a detection and prediction window, and that allows the maintenance system to receive this auto-generated work order. So that handshake between maintenance, predictive maintenance, and the preventive maintenance schedule really allows interoperability and allows ease of use by the maintenance organization. This is an example actually from a maintenance software, one of the maintenance solutions out there, and an example of that work order that was auto-generated by a predictive system, right? And usually those work orders are flagged differently so that they are not confused with other preventive maintenance work orders. So, with a predictive tool, you're not going to stop doing your PMs. but there are specific failure modes that a predictive system can capture quite well, such as spindle bearing failures and ball screw failures of different types. And for those failure modes, those predictive work orders can then be auto-generated in your maintenance system. So I think these are two important use cases that we wanted to share with you today. You may have attended a lot of presentations about AI and doing predictive maintenance. A lot of them really focus just on how to do predictive maintenance and the algorithms and the dashboarding and so on. But what we wanted to really infer here is how can you go beyond predictive maintenance and really add further value to other key roles within your organization. For example, scheduling maintenance and scheduling production, which are two key pillars of your smart factory operation. So to summarize, two concluding slides, okay? And if you have any questions in the meantime, please drop it in the chat window. The first slide is really, how do I start, okay? We always follow the mindset of, it's good to think big, okay? I want to do IoT, I want to do AI, I want to do predictive maintenance, I want to do predictive production scheduling, and so on and so forth. But it's important to start small, and it's important to prove value small, and then have a strategy to scale it fast by utilizing templates and utilizing domain knowledge. And therefore, if you think about it, thinking big is about assessing where you are today and having the training so that there's awareness. You attending a webinar like this today is a great example of continuing to be aware of what's happening around you and some of the best practices that are being adopted in the industry today. Different manufacturing plants have different levels of digital maturity, and it's important to assess where are you today, people, process, technology. What is maintenance doing? What is production doing? What is scheduling doing? And once you have that assessment, you're able to have key deliverables from that assessment, basically a design, okay? Where are my gaps? And what is a clear statement of work? What do I need in terms of hardware, software, services, in order to have the right data and the right mindset to embark on starting small with a proof of value, okay? Many of the things, actually all the things we've shown you today are not concepts. We don't call it a POC. They are truly available solutions out there that you should assess for your business and implement a proof of value that combines business value and an ROI setting with the technology that makes sense for your business and starts helping you prove value very quickly in a short period of time. And we see these solutions implemented usually in under 3 months and value derived within 3 months of the implementation go live. So we're talking, 6 months of effort that allows those solutions to start small and prove value quickly. And last but not least, scaling is a challenge, could be a challenge in itself. But if implementations are done properly and trained properly and templates are in place, we believe in the value of a COE, a center of excellence, which is, call it a digital steering committee that can learn these tools and templates and start to scale them in an intelligent way across the enterprise. So we really appreciate your time today and understanding of where the industry is heading and what companies are doing today to further leverage AI. The mindset is really think big and start small. It's about making it operational today by implementing a proof of value that combines business with technology. There's a lot of use cases when it comes to smart connected factory. And in previous CFE webinars, we went much deeper into predictive maintenance. But in this setting today, we wanted to talk to you about how predictive maintenance can actually leverage and really turbocharge scheduling as well as production planning. And last but not least, technology is great. And we find that technology is never a hindrance to success. It's usually people and process of adopting that technology. So evaluate where your weakest link is, because that is as far as your benefits will accrue. So assessing where you are, training, attending sessions like this, and then implementing technology in the right place at the right time will ensure success for your business. This is our information. Feel free to email us for a copy of the presentation, connect with us on LinkedIn, and I'm sure the recording of the presentation will be available afterwards. Kevin, back to you. Thank you.
Well, thanks, Mo and Edsel, for what was really an informed discussion about the systems that are found in today's modern manufacturing enterprises. For our audience, type your questions for Edsel and Mo in the Ask the Question box on the screen. We'll get to as many questions as time allows. Questions that we don't get to today will be posted online with the archived version of this webcast. Remember to download a copy of the presentation and additional resources that may be available using the Event Resources tab. My first question today is for you, Mo. And we've talked about IoT-based integration. And I mean, I think that the primary benefit of IoT-based integration is that real-time information that comes in. But why don't you talk a little bit about the challenges of achieving that kind of integration and where specifically you see the benefits arising?
Yeah, absolutely. I can maybe start with the benefits piece, and Edsel can add with the challenges piece. You know, it's important to define your success criteria. And I think 4 areas that would govern success is, number one, that domain knowledge and the technical expertise behind what you're trying to do is important. So bringing in the same room your maintenance person, your production scheduler, your IT, and having an informed decision about technical requirements. Second, I would say time to value is very important, speed. Utilizing templates, utilizing best practices, such as the CNC machine example that Edsel was showing, allows you to accelerate the implementation of these sometimes perceived as complex solutions. Third is scalability. Once we think big, start small, and implement a template, and you have 100 CNC machines across 3 to 4 plants, those solutions become scalable, and they can be scaled by your own internal team members with training. And these factors of, you know, domain knowledge, technical value, speed to adoption or value, scalability, all translate to return on investment to the company and improving uptime, improving quality, improving labor, improving spare parts. I think those are key benefits, and Edsel can address the challenges.
Yeah, great, Mo. Thanks so much. And in fact, Edsel, let me ask you, what are some of the key challenges in integrating predictive analytics, specifically with maintenance or production scheduling systems?
Okay, with regard to the topic that I mentioned, there's definitely some technical challenges with regard to integration. But now, since that most software have APIs, the interfacing between like the MES or ERP software and a predictive maintenance or predictive analytics software is becoming less of a challenge as compared to before. So documentation for integration or APIs is important, and making sure that there is a key technical resource for the 2 software solutions to be integrated. As for any manufacturing solution, it is important to integrate the software solution into someone's daily routine. So this is more the culture side of it. The advantage of an integrated solution is that you're introducing one new piece of software versus 2 or more. So the value of integration is having a complete picture of one solution versus several.
Good, thank you. You know, resources planning and capacity planning is just so much at the core of the systems that are used in manufacturing. And of course, scheduling problems are classic computer programs. And what is always interested in me is that it's really a 2-tier system. You've got a scheduling system for daily and weekly, and then you've got an ERP system for monthly or looking out over an even wider horizon. Could you talk just a little bit, Edsel, about how that gap, if you will, in terms of fidelity, how you manage that in the course of integrating it with preventive maintenance, or even talking about scheduling itself over time?
Yeah, so that be considered, and probably the distinction between short-term and long-term depends on the objective. So for what I discussed during the presentation is more like short-term planning, because that in that essence, the objective there is more for early detection. But if we want to extend the maintenance window, for example, that's more for long-term planning. So we've had a past example with semiconductor manufacturing. The predictive maintenance system was monitoring the health and predicting the future health of a component that is replaced every 3 to 5 months, for example. Now, with this insight, what we can do is we can use the predictive maintenance information to extend that predictive maintenance time. Instead of doing it between 3 to 5 months, maybe I can extend that longer. So that can help with future planning.
Good, thank you. Edsel, Mo, let's talk a little bit about the emerging market for solutions for predictive maintenance and scheduling. Automation companies, software companies, machine and equipment suppliers, and even component providers like bearings are introducing their solutions for predictive maintenance. And, typically we see a market grow with a huge number of players, and then it gets to some point where it starts to consolidate. What's your take on the current state of the market, and where do you think it's going to evolve to?
Yeah, I fully agree with you, Kevin. A lot of the companies that are making the parts like bearings, they're coming up with their own solutions or partnering with others. And the reason is they want to have what we call a smart connected product strategy. They want to leverage AI, they want to leverage Industry 4.0 and IoT, and they want to offer new models of service to their end customers. They want to offer predictive maintenance as a service, remote monitoring as a service. They want to improve customer satisfaction by offering these tools and having customers running their parts in a just in time, just in a request of spare parts can be predictive, right? However, my take is two things. Number one, interoperability is very important, and Edsel kind of alluded to it. The ability that any OEM out there should support standard APIs and protocols so they can speak to the outside world. So things like using IO Link with sensors, using MQTT, using REST API is very, very important. Otherwise, you'll find that this manufacturer will become quite siloed. They will be considered as a proprietary type of solution or hardware, and this would really impact their adoption in the market. So interoperability is very important, even if you have your own solution. Number two is a platform approach, right? Companies are always looking for a strategy to scale fast across their enterprise. So by having interoperability, even if you have separate software solutions for each bearing manufacturer you have, the ability to aggregate that data together and have a platform, an IoT platform, or whatever you have within your organization, allows that data to be consolidated, aggregated, and then you can enable further analytics on that data. So my advice looking at the market is always interoperability is key for success and scale. And then second is having a platform approach to scale the solutions in a templatized way allows companies to scale fast and adopt fast.
Great, thanks, Mo. Edsel, one of the biggest issues in manufacturing markets and enterprises today is the lack of skilled labor. Do you think the average manufacturing enterprise, the mid-sized manufacturing enterprise, has within it the capabilities of not necessarily implementing a predictive maintenance system, but of operating it over time on its own, or are sophisticated skills not needed once the system is up and running?
Okay, I think I understand. So now for IoT or predictive maintenance and quality solutions and the integration of these solutions with MES or other manufacturing enterprise solutions, one of the major tasks, which is the bulk of the task, would be the integration, as well as making the unified dashboard and making the software intuitive enough so that it's easy to use for the end user. So the configuration would take some engineering or IT effort, but once it's been integrated, using the integrated solution should be possible. should be easy to use by operators, maintenance personnel, and manufacturing maintenance, as well as process engineers, as long as it comes with appropriate training and guidance. So sophisticated computer skills should not be needed to maintain the integrated solution afterwards.
Good.
Fully agree.
Yes. Question for both of you, and that is, please talk for a moment about some of the other IoT-based integrations that are going to be prevalent in manufacturing going forward, and kind of looking at the idea of the sensor level, the connectivity level, and the analytics level being applied in different functional areas. Put on your prediction hat and tell us a little bit about what other types of things that are going to be happening. And Mo, why don't you take the first look at that?
Well, Kevin, I don't have a nice hat like you, but I'm going to give it a shot. Okay. And you know, we
All
talked
right.
a lot about maintenance and quality and scheduling and so on and so forth. And it's all technology. But the example I'm going to give is, you know, connected assets, you got connected products, but also connecting the worker is very important. So there is a lot of connected worker applications now that are leveraging IoT and leveraging this type of data that is being captured and augmenting it to improve safety and training and even the way that they do work. So AR, or augmented reality, is a very interesting field that is used heavily to improve safety training as well as working approaches. And I can give you a quick example. Imagine you're a maintenance person walking around with a glass, and you're looking at your machines, and the glass immediately picks up while you're walking that a specific machine has a specific issue. So by taking that predictive data, health and predictions and so on, you can actually empower the maintenance organization while they're doing their maintenance activity, you know, A, how to do maintenance for the machine in a better way, and then B, you know, be informed if a machine is going to fail while they're doing their regular, you know, maintenance walkthroughs through the plant. So connected worker, augmented reality applications are really, they're here today, and they're really improving the way workers are using technology on the shop floor.
Great. Edsel, would you like to add something?
So my observation is that there's still a lot more disparate or independent systems in manufacturing shop floors that can be integrated together. So one thing that we're focusing on, at least with our business, is that predictive quality. What we are coming up with, we want to integrate manufacturing processes with inspection or quality inspection, and then we also have metrology, for example. If you are able to find out machine health and the process parameters, probably you don't need to test a product or part for too long. And with the integration with metrology systems such as a CMS or a coordinate measurement system, this is especially true if the degradation of a specific component affects the product quality. For example, in the feed axis or ball screw example that I used in my illustration, if a backlash is detected, the integrated system can initiate a measurement activity to make sure that the surface roughness of the machine part is still up to spec, for example. So again, there's still a lot of opportunities. We just have to make sure we're on the lookout for them on how they can be combined with the other existing applications out there.
Well, great. I think that's about all the time we have for today, but I want to thank both Mo and Edsel for what I thought was a really informed discussion, and we'll look forward to having you back again. I'd also like to extend special thanks to our sponsors, Aviva and GE Digital, for sponsoring today's event. And now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it, because we use this information to improve our webcast. And finally, on behalf of Plant Engineering, I'd like to thank you for attending. This concludes our webcast. Thanks, and we'll see you next time.
Thank you so much.